Okay, so today we're going to be discussing domain and restricted domain. From last night's video, we should know how to define domain already. So I'll give you a few seconds, pause the video, define domain, and then click play. Okay, so everyone should have domain is all the x values. That's what the domain is, all the x values. Now, if we were to look at this, look at the expression and tell me what the value of x can't be. Notice can't is underlined and bolded, you can't miss it. So if we look over here, x plus 4 over 2x. If we put that, we know that x cannot equal 0 because of fraction rules. Anything divided by 0 or 0 in the denominator is undefined and we can't find it. So we know x cannot equal 0. So if we look here, finding domain from an equation, sometimes instead of thinking of what you can have, think about what you can't have. Thus, by process of elimination, we know what we can have as our domain. So in this particular expression, we know that x cannot equal 0, but it can equal every single other number in the number system. Okay, so looking at expression 1 or function 1, we see that it's 2x squared minus 9. So if you remember from last night, when we had a parabola, and this is a positive parabola, it looks something like this. That's what parabolas look like. So if we look at our domain, we remember it was in interval notation, we have negative infinity, comma, infinity, parentheses. But another way we can say this is all real numbers. Or the symbol for that is kind of 2 lines and an R. This is the symbol for all real numbers. So now looking at question 2, 5 over x plus 9, remember we're looking at what x can't be. Can't in big bold letters. So we know that x cannot equal negative 9. Because if we plugged in negative 9 for x, it would be 0, and that's undefined. So we know this is our domain. But how do we write x does not equal negative 9? So what we will do is anywhere to the left or less than negative 9 is defined, so we know that's to negative infinity, comma. We know negative 9 cannot be included, so we write negative 9, parenthesis. Now here's a funny symbol that is very, very important. It looks like a giant U. This is called union. What union means is the domain is also contained in parentheses negative 9 to infinity. So union kind of adds both domains together, but we know with parentheses negative 9 is not defined, not included, therefore this is our domain. Union. Remember, anytime you have 2 different domains that are possible, it's union. So looking at question 3, the square root of x minus 3. So just like last night's video, we have a square root, and we know that x has to be greater than or equal to 3, because if it's less than 3, 2, 1, etc., we have a negative under the radical, and we know that's not allowed. So x has to be greater than or equal to 3. So very simply put, our domain is bracket 3, because it can be 3, because 3 minus 3 is 0, to infinity with a parenthesis. Remember, parentheses always goes with infinity. Now, looking at question 4, looks similar to question 3, but now the radical is in the denominator. So it can no longer be greater than or equals to 3, because then we'd have a 0 in the denominator, which we know is not allowed, which would make the function undefined. So we say this domain is x is greater than 3. So now we write parentheses 3, comma, infinity, parentheses. Because we know now 3 is not included in this function. It is not included in the graph. It will be undefined if it was 3. That's the parentheses. Parentheses not included, brackets included. Okay, so now we're going to talk about the difference quotient and where it comes from. So let's just label our axes, x and y axis. So I'm going to put a random slash here, and that'll be x, and here, random point on the y-axis that I can write as f of x, because remember, f of x and y are the same thing. So if I were to put a point at this spot right here, the point would be at x, comma, f of x. Now we're going to travel along the x-axis right here at a distance of h, so that this point now becomes x plus h. So then my corresponding y value up here would be f of x plus h. So if we were to put a point right here, we could label that the point x plus h, comma, f of x plus h. So the difference quotient is really simple. It is finding the slope between these 2 points right here. So if you remember, the slope formula is m equals y1 minus y2 over x1 minus x2. So now we're going to subtract our y's and subtract our x's using the slope formula. So we have our y value here and our y value here. So y1 is f of x plus h minus f of x over x plus h minus x. And what we're left with when we cancel some stuff out, we have a positive x here, negative x here, x minus x becomes 0. So we are left with f of x plus h minus f of x over h, which is the difference quotient. Okay, so now we're going to apply the difference quotient into this problem right here. So we have f of x equals negative 2x plus 4, and we need to find this formula. So remember, this is our input, So wherever we see an x, we're going to replace it with our input. So I have negative 2 times x plus h plus 4 minus the original function, negative 2x plus 4 over h. And remember, h cannot equal 0 because it'll become common sense. Anytime you have a variable in the denominator, it cannot be 0, otherwise it'll be undefined. So now we'll distribute the negative 2, and we get negative 2x minus 2h plus 4. Distribute the negative here, and we get plus 2x minus 4 all over h. And now we combine like terms. So negative 2x cancels with positive 2x. Positive 4 minus 4 is 0. That cancels out. And we're left with negative 2h over h. We can cancel these h's, and we're left with negative 2. So if we look at this particular problem, we have two inputs, one here and one here. These are both inputs. So we're going to start with this guy and substitute in, so it'll look like this. 5 times 5 plus h minus 5 plus h squared. Now my second input minus parenthesis 5 times 5 minus 5 squared all over h. So now remember, right here we have 5 plus h squared, which can just be written as 5 plus h times 5 plus h. And when we solve that out, we get 25 plus 5h plus 5h right here, which would be 10h plus h squared. Now if we take care of the first one, distribute the 5 here, we have 25 plus 5h, and we have minus 5 times 5 is 25, minus 5 squared is 25. Now distribute the negative to all these inside here, and we have 25 plus 5h minus 25 minus 10h minus h squared minus 0. Still all over h. I know I forgot that there, but it's still all over h. So now we'll reduce. We have a 25 and a minus 25. We have 0, that cancels. We have a 5h positive, negative 10h, that reduces to negative 5h. And we have this h, negative h squared here, minus h squared over h. And when we reduce this, h and h becomes a 1. H squared divided by h, take away the squared, so you're left with negative 5 minus h. Okay, that's it for this video, and we'll see you in class tomorrow to practice some more.